For this last exercise, we're going to compare linear search versus binary search by timing a linear search and a binary search on a fairly large data set. I have the linear search code and the binary search code already loaded into this program, which is called time search. And what we're going to do is we're going to create an array, unsorted, and then search it using linear search. Then sort the array, and then search it using binary search. To make things work the most efficiently, we need to make sure that the array that we use does not have any duplicates. That can cause some issues for our sorting. So to do that, we're going to have to do a little creative hacking, as it were, to get an array that doesn't have any duplicate numbers using random number generation. So what I'm going to do is I'm going to first use an array list, because using an array list, I can very easily check to see if an item is already in the array list before I add it. And that way I don't have to add any numbers that are already in the data set. So I've created an array list. Now I'm going to write a loop. And first thing I'm going to do is generate a random number. And we'll do that in the range of 100,000. That way I can be sure I'm not going to put any duplicates into an array of only 10,000 numbers. So the first step is to generate a number. Now I write an if statement and I say if not nums contains n, then we want to add it to the array list. Now, once we have it in the array list, then we're ready to convert it to an array, but first we're going to print it out. And we'll go ahead and do that now. We want to display all the numbers so that I can see what numbers I'm working with. It's a lot of numbers, I agree. So I'm not even going to try to print it out in any particular formatted order. I'm just going to print them out using a for each loop. Let's print an empty line right here. Now I'm ready to take the numbers out of an array list and put them into an array. So the first thing we're going to do is declare our array. Then we'll write a quick loop. And notice we're having to cast the number coming out of the array list into integer because remember that array lists store data as objects. You saw that up here in the for each loop, or you should have seen it, although I didn't mention it specifically. Now we're ready to search using linear search. So we're going to ask the user to enter a number. So to do that, the first thing we have to do is create a scanner object. We'll do that first. Then we'll prompt the user. Then we'll get that number from the user using nextInt on the input. Then we'll get the system time in nanoseconds. Call the lsearch method. Get the stopping time, or the stop time. Then figure out the duration, which is stop time minus start time. Then display a little message to the user. Now we're ready to move to binary search. So to do that, we need to sort the array. So we call arrays.sort with our array. Prompt the user again. Get the number from the user. Call the binary search method. Record the stop time. Compute the duration. And then display the time. That's all we have to do. Make sure we've closed out the method, main, and the class, and we have, so we'll save the file. Compile it, then run it. There's our long list of numbers. Let's let that run through. Let's pick a number out somewhere. Just pick one that's not too far long. 18,031 will be the number that we're going to pick. And we see that its linear search time took 54,756 nanoseconds. Let's do the same number again using binary search, and notice that it took just a touch longer. So let's do that again. Pick a number farther down. Let's look for a very large number. 91,375. That one took 40,019. So notice we're still getting a little bit worse time for binary search. So let's go a little bit higher in the numbers. We can find one. We're not going to get much higher than in the 90s. 98,207. So you see the time there. Run it again. So you see we're still very close. Let's go back and take a look at the program. And what we might do is we might increase the size of the array and increase the numbers generated. And let's see what happens when we run it again. Clear the screen, compile, and then run. Printing is going to take a minute as we're trying to print a very large number of numbers. So let's be patient with it while it goes. It took quite a while to get the numbers to display. I/O is always very slow on any system. It's going to take a minute too as we scroll through the numbers. Hopefully this will give us a better sense of the difference between linear search and binary search. Okay, so we'll try 370052. So we see it takes almost 687,000 nanoseconds. In binary search, it took 46,724. Let's run the program again, although this time, of course, we're going to have to wait for the numbers. There we go. So now we're about ready. Again, the scrolling will take just a minute or so here. Hopefully not too long. All right, so let's pick a number. 885,880. Took 916,000 nanoseconds, give or take a few. Do it again in binary search. 36,527. So clearly you can see that the binary search method is much more efficient for very large data sets. For smaller data sets, linear search actually is a little bit faster. But when you have a lot of data, it's always best to use binary search. The difference isn't so great that you shouldn't just go ahead and use binary search all the time. And in fact, most of the search methods that are built into most languages are based on binary search anyway. And as I always say, if there's a library search method available, always use it over something that you build yourself. It's instructive to build these methods yourself to see how they work and to practice with programming. But in quote-unquote real-world programming, it's always best to use something that's already built in. And with that, we've wrapped up this exercise and we've finished this chapter on sorting and searching.